Welcome to the updated FreeCAD Ultimate Beginner's Guide. This has been updated for FreeCAD 1.1 and above, as there has been significant changes from FreeCAD 1.0. FreeCAD is a powerful open source CAD package, and this course will guide you through FreeCAD and teach you how to create functional designs from start to finish. By the end of this course, you'll be ready to use FreeCAD for your own projects. Before we dive in, the first step is to get FreeCAD installed on your system. First, we need to download and install FreeCAD from the official website. When you launch FreeCAD for the first time, a setup window will appear, where you can choose language, units, navigation style, and interface theme. I will be using the dark theme for this course. You can also go to the top menu, Edit Preferences, to search for and adjust these settings at any time. If you don't see this window appear, you can click on the button Open First Start Setup on the Start page. If you don't see the Start page, then go to the top menu, Help, and click on Start Page. Once you set up those basic settings, you'll see the main FreeCAD interface. Think of FreeCAD like a fabrication shop with multiple specialized workbenches, each with its own tools. You can switch between these using the drop-down in the top toolbar. We'll be using the Part Design and the Sketcher workbench for modeling, then move to the Assembly workbench to assemble everything together. The Part Design workbench is especially beginner friendly because it guides you through a clear, linear parametric workflow. Let's create a new document so we can explore the FreeCAD user interface. The FreeCAD workspace consists of toolbars and panels. In the center is the 3D view, where your model will appear. On the left, you'll see the model panel, and on first setup, you should also see the task panel. If the task panel is missing, go to the top menu, View, Panels, and make sure the task panel is checked. To keep things simple, we'll only use 2 panels. Uncheck any others, including the report view. The report view often pops up when errors occur. To prevent this, go to the top menu, Edit, Preferences. In the General section, look for Report View and uncheck both Show on Error and Show on Warning. You'll still see the notifications in the status bar. Now to the panels. If you hover your mouse over the task panel, the top bar of the panel will appear, where you'll see several options. The first icon is a toggle button. Clicking it will hide the panel to save space. However, it can sometimes be tricky to bring the panel back. You need to move your mouse to the far right of the screen until a small hint appears, then left click it. Or you can use the shortcut Ctrl and the right arrow on the keyboard. The next icon toggles the overlay mode, or returns the panel to its previous floating position. I recommend just watching this next part, rather than trying to follow along. These panels can be docked and combined with others. To do this, click and drag the top bar of the panel, then hover it over another panel until it becomes blue. This blue highlight shows where it's going to be docked. Release the mouse button to dock it. However, this has a tendency to lead to panel gymnastics. So for this tutorial, we'll keep the task panel simply docked on the right side. At any time, you can press the Escape key to cancel the dragging operation, rather than trying to drag the panel back. Now let's move on to navigating the 3D view. First, we need to choose the navigation style. Click the drop down at the bottom of the screen to select your preferred control method. I personally prefer touchpad controls. When selected, the drop down updates. Hovering over it shows the full list of controls. In this case, it shows both the touchpad and mouse controls. Let's get familiar with the main navigation shortcuts. On the top menu, go to View, Toggle Axis Cross. This displays a helpful axis showing the origin point and allows a visual indication of what's happening when we navigate the 3D view. To zoom, use the zoom gesture or shortcuts for your selected navigation style. As you zoom, you'll notice the scale value in the bottom right of the screen updates in real time. Next is rotation. With the touchpad navigation style, hold down the Alt key and move the mouse, or use the touchpad. you'll see a pink rotating point appear. This is the center of rotation. Move the mouse up and down or left or right to orbit around the 3D view. For panning, hold down the Shift key or use the corresponding touchpad gesture. A move icon will appear, allowing you to slide the entire view left, right, up and down, etc. In the top right hand corner, you'll see a small navigation cube. As you rotate the 3D view, this cube rotates with you, giving you a quick visual reference of your orientation. There's also a coordinate system displayed at the bottom right corner. You can customize both of these widgets in the preferences. Clicking on the faces of the navigation cube, top, front, right, etc., switches your view to that viewpoint. You can also click the arrows or the edges of the cube, allowing you to rotate the view. You will learn more about navigation as you build your first model. Every part we create in FreeCAD is built inside a body. The body acts as a container to hold all the features of our part. To create a new body, click on the body icon in the toolbar. In the tree view on the left, you'll see a new body icon. The body is currently active, as it's shown in bold. This tells FreeCAD any operations will be applied to this body. If it ever loses the active status, you can reactivate it by double-clicking on the body to toggle its state, or by right-clicking it and selecting Active Body. When you expand the body, you'll notice the origin nested inside. At the moment, the origin object is hidden. To make objects visible, you can either click on the eye icon next to it, or simply click on the object and press the spacebar to toggle its visibility. We can clearly see the three planes and the three axes that make up the origin. If you haven't already, start a new document and enter the Part Design workbench. Via the drop-down menu at the top, you'll see that the Part Design toolbars have become active. These toolbars might look out of place at first. If you hover the mouse over the two vertical lines between the toolbars, you'll see the name of each appear. From the pop-up hint, you'll notice that there are workbench-specific toolbars, like the Part Design ones, and the standard toolbars, which appear in every workbench. I will increase the size of my icons on the toolbars to make it easier for you to follow. Go into the top menu, Edit, Preferences, and using the search for the word icons. Selecting Size of Toolbars, I will increase it to the next stage up. Let's organise them into neat rows. Hover over the dotted lines on the Part Design toolbar, then click, hold and drag it, and we'll create a single clean row for all the Part Design tools. If you find that the toolbars can't be dragged, right-click anywhere on the toolbars and uncheck Lock Toolbar. While we're here, make sure all the Part Design tools have a check mark by the side of them, so they're all visible. By dragging a toolbar down into the 3D view, a new row will automatically appear. Try to arrange your toolbars so they look similar to this layout. It's not strictly essential, but having them neatly organised makes it much easier to follow the course. Here I have the standard toolbars at the top and workbench specific tools underneath. 3D Sketch is the foundation of almost every part we create in the Part Design workbench. Let's hide the origin that we made visible and start sketching. To start a new sketch, click on the sketch icon in the toolbar. FreeCAD will prompt for the attachment of the sketch. We'll select the XY plane from the 3D view. Notice that the navigation cube now shows top. FreeCAD will automatically switch your view so it's perpendicular to the selected plane. So we're looking straight at our sketching plane. You can reposition the view at any time using the standard navigation shortcuts. If you ever forget them, just hover over the navigation style at the bottom, and the helpful reminder will appear. I can rotate the view around my sketch from different angles. Whenever you want to return to a perfect perpendicular view of the sketch, simply click the View Sketch icon in the toolbar, or right-click Align View to Sketch, and this will reorientate the view for you. We'll draw one half of the part, then use a mirror operation later in the part design. First, we need to make sure that two very important settings are enabled. In the Constraints section of the Task panel, you'll see a drop-down menu. Make sure both auto constraints and auto remove redundant constraints are checked. We'll explain why these settings matter in a moment. You'll notice a red horizontal line, the x-axis, and the green vertical line, the y-axis. These meet at a sketch origin. These are selectable and can be constrained to. Let's start by creating a rectangle. Select the rectangle tool from the toolbar and move your mouse into the 3D view. You'll see a coordinate value appear next to the cursor. As you move the mouse left and right, the x coordinates change, showing negative values to the left of the vertical axis, 0 on the axis, and positive values to the right. At the bottom of the screen, the status bar gives you helpful hints. I'm going to start my rectangle roughly 50mm away to the left of the vertical axis. Note if you keep the mouse in the same position and zoom in and out, the actual distance from the axis doesn't change. The 3D view is actually being scaled. Click once to place the first corner. The status bar now prompts you to pick the opposite corner. Don't do that just yet. Instead, move the mouse downwards slightly. Now you can see the rectangle, and also you'll see the dimension fields, known as on-view parameters, or OVPs. Let's type 50 for the width, press the Tab key on the keyboard, and then type 50 for the height. Even though the hint is still asking you to pick the opposite corner, the dimensions are now locked in, and your mouse is free to move. Because we enabled auto constraints, we can automatically constrain to the objects on the screen. Hover over the vertical axis and watch the cursor closely. You'll see a point on object constraint appear. This is telling you that FreeCAD will attach the geometry to the vertical axis once you click. The cursor shows you where this is going to be attached. Misclicking or accidentally constraining it to the wrong element is a common early mistake in FreeCAD. Once we've left click, the rectangle is automatically dimensioned, and then we can use the right click to exit the tool. In the task panel, you'll notice that the sketch has 1 degree of freedom. This means that part of the sketch can still move. If we click on the link, then the geometry is selected in the elements, and we can see it can still move along the y-axis. Our goal is to fully constrain the sketch, to make 0 degrees of freedom. This is considered good practice in parametric modeling, but it's not essential. To do this, we'll add a symmetrical constraint. We already have a point and object constraint, and auto remove redundant constraint is enabled. This is important to note for the next step. First, we need to make sure that everything is unselected. In the 3D view, click in an empty area. This will deselect anything that's already selected. Then select the top right hand corner of the rectangle. Clicking on the point so it highlights in green. Then select the bottom right hand corner. There's no need to hold down Control. FreeCAD uses a hungry selection. If you accidentally select a line, simply click it again to deselect it. Now select the midpoint. This will be the origin point. Apply the symmetrical constraint by clicking on it in the toolbar. The rectangle will center itself and the sketch should turn completely green, indicating it's fully constrained. Notice that the point and object constraint was automatically removed. If we hadn't enabled the auto remove redundant constraints option, this would have caused a redundant constraint error, and we would have had to delete it manually. This may be a lot to take in for the first lesson, but I know some viewers would have missed this important setting earlier. Next, let's round off the corners using a fillet tool. We can select it from the toolbar, but if you don't see it, it's available from the right-click menu and select Fillet. The tool is now active. Hover over one edge and click, then hover over the adjacent edge and click again. A fillet will be created. Repeat this for the bottom 2 edges. Then right-click to exit the tool. You will now see that the sketch has degrees of freedom again. Let's set the radius of the fillets using the multi-purpose dimensioning tool. Select one of the fillet arcs. A radius dimension will appear. The status bar hints tells us that we can use the M key to toggle between radius and diameter mode. We want radius. Move the dimension to a convenient spot and click. Now we can type in 10 mm. and press enter. Instead of dimensioning the second fillet, we can make both radii equal. Click on the Equal Constraint tool in the toolbar and select one fillet arc, then select the other. An equal constraint symbol will appear, and then right-click to exit the tool. The sketch should be now fully constrained. But we also need holes. We can add them in the same sketch. Select the Circle tool. Hover over the center point created by the top fillet. You'll see a coincident constraint appear automatically. Click to place the circle center and then move the mouse outwards. And click again to set the size. Repeat this process for the bottom fillet. We'll now make both circles the same size. Right-click to cancel the Circle tool and simply select one circle, then the other. Click on the Equal Constraint tool in the toolbar and use the Dimensioning tool. And set the dimension to 10mm and press enter. Then right-click to exit the tool. The entire sketch should now be green, fully constrained. We can now clean up the constraint labels by dragging them into position. We can now exit the sketch by clicking the Close button in the Task panel, and our sketch is ready for the next operation. Let's save the project by going out to the top menu, File, Save, and name the file base_part, and click Save. Volume can be added to a sketch using additive operations, which extrudes the sketch in different ways. The most basic is the pad operation, which extrudes the sketch in a straight direction. To use the pad tool, the sketch must be first selected. When you exit a sketch, it will automatically be selected. If not, we can select it from the tree view. Once the sketch is selected, click the pad icon in the toolbar, or go to Part Design on the top menu, Additive Features, and then Pad. In the pad options, the length of the extrusion is controlled by the length parameter. Let's set this to 5mm. We can click on the 3D view to see the model update. Once you're happy, click OK. You have now padded the sketch by 5mm, turning it into a solid feature. The operation has been added to the body as a feature, and the feature will have a small arrow showing that this is the tip feature. It indicates which feature is currently active at the end of the model. Every time you add a new operation, another feature will appear in the body container. The tip is automatically moved to the latest feature that you've created. Removing volume in part design is done using a subtractive operation. Instead of adding volume like the pad tool, we'll use a pocket. This removes material in the shape of the sketch. We need to clear out a section from the top of our base feature using a simple single profile attached to the side. First, select the side face of the pad. Then click on the new sketch. This will automatically attach it to the selected face. The map mode of the sketch will be set to flat face. Let's rotate the view to see where the sketch plane is placed. To help us sketch accurately, we'll import some external geometry. Click on the Create External Projection tool. Then select the top edge of the pad. This edge will now be available as a reference in our sketch. We don't want the imported geometry to be part of the defining shape, so note whether the imported line is solid or dashed. This may be a bit hard to see. We can hide the previous pad operation in the tree view to get a better look. At the moment, the line is solid, meaning that it's defining geometry. Right-click to cancel the tool. Let's make sure that nothing is selected. Select the geometry you've just imported. Then select the Toggle Construction Geometry button from the toolbar, or right-click, Toggle Construction Geometry. This geometry will be changed to Construction Geometry and will be seen as dashed. Remember to make the pad operation visible that we just hidden. Before proceeding, make sure the top tools are in white. If they aren't and they're in blue, make sure we have no geometry selected and click on the Toggle Construction Geometry button. Now let's select the Polyline tool. Use the View Sketch icon to reset our view. and zoom in for better control. Hover over the vertical axis. You'll see a point and line constraint appear. Click to place the first point. Then move the mouse pointer to draw a line horizontally across. Next, click and draw a line upwards. This will be at an angle until it connects to the imported geometry. You'll see a point and object constraint appear. Click to set it. Continue the polyline to the right, hovering over the imported point of the external geometry until we see the coincident constraint appear. Left-click the mouse again, then bring the mouse down to close the profile. Snapping to the starting point and left-clicking to set the coincident constraint. If the polyline hasn't closed, right-click to exit the polyline, and now right-click to exit the polyline tool. We now have a closed sketch. We can see it's closed as the points are all in red. If this point here is not in red, and we can demonstrate this by clicking on the point and hitting the delete key on the keyboard, then these lines are disconnected. And this will lead to errors when we close the sketch and run an operation against it. We'll get the error "why not closed." If we get into this situation, inspect the sketch to find those gaps. Or we can run the sketch validation tool. In the panel, select Highlight Troublesome Vertices, which will highlight the problem. The Find Missing Coincidences can also be used as well. Let's close the tool and re-enter the sketch. Reattach the points by box selecting them. Click and hold the mouse at the top left position and draw a box around by sliding the mouse down to the bottom right. Release the mouse and all within the box are selected, and then use the coincident constraint. The points go red and you're good to continue. Let's add some dimensions and constraints. Select the Dimension tool, select the short vertical line and set its length to 2.5 millimeters. Don't right-click, keep the tool active. Select the bottom horizontal line and set its length to 24 millimeters. Now we'll add an angle dimension. Select the slanted line, then select the horizontal line. An angle dimension will appear. Set this angle to 114 degrees and press enter. We can now right-click to exit the tool, and the profile should be fully constrained. If not, check that we have horizontal constraints added. The line should be straight. Close the sketch to return to the part design. The sketch should be already highlighted and ready for the next operation. If not, select it from the tree view and click the Pocket tool. You'll see material being removed from the part. This time, instead of setting a specific length, open the Type drop-down and select Through All. This removes material completely through the whole length. Let's click OK. We've created our pocket feature and the body is complete. Because we have imported the geometry, we can change the length of the first pad. The pocket feature will adapt automatically. Let's set this back to 5 millimeters. It's advisable to give the body a more descriptive name. Right-click on the body and rename it to Base. You can also add a comment, i.e. a description, to the body, which will be visible in the tree view. To do this, we first need to enable the description column. Right-click anywhere in the tree view, go to Tree Settings, then click Show Description. A description column will appear. To add a description, click on the body, make sure your cursor is in the description column, and press the F2 key on the keyboard to edit it. I'll enter version 1.0 and press enter. We've now successfully added a description. This is not necessary, it's totally up to you to add this description if you want to. You can rename sketches and operations also, but for small projects like this, it's not necessary. But when you get into large parts with multiple sketches, especially those for loss where you have multiple profiles, then this may make it easier, especially when you revisit the project in the future. We now have one side of our base. Next, we want to mirror this to the other side. FreeCAD has mirror operations. We can mirror individual features, but in this case we want to mirror all the features, basically the entire body. The body is selected in the tree view. It's worth mentioning another way of selecting it, rather than just clicking on the tree view. Let's make sure that everything is unselected first, by clicking on some blank area in the 3D view. Click once on any face of the part, and watch the tree view. This selects the face. Also watch the Data tab. Click a second time on the same face, we can now see it's selected the feature. Clicking a third time, this selects the entire body. If we look at the tree view, our selection has moved up to the body. With the body selected, go to the mirror operation. In the dialog, it asks whether you want to mirror the body or just the tool shapes. Since we're mirroring all the features, select the body. You'll now see the body being mirrored, but it may be using the wrong mirror plane. We want to mirror across the origin YZ plane. So let's quickly pause for a second. It's not obvious from the screen which planes we're mirroring across. The origin is here. It's been made visible. We want to mirror across this way. To make this easier to see, let's come up to Edit, Preferences, and search for Datum. And in the general, in 3D view, we see we have datum size, which is here. So we can increase this datum size, let's say to 300%, and hit apply. So it makes it much easier to see. Let's hit OK. But still not obvious which plane to mirror across. If we come over to the origin and show both the X, Y, and Z axis, it now becomes obvious which planes they are. So we have the YZ plane running this way, which is this plane. And then I can hit OK. You've now completed your first part, the base. Remember to save, and we can move on to the next part. We have several options for starting a new part. We could hide the current body and create a new body. This will be marked as active, and then when we start modeling, all new features will be placed in that body. Or, in this case, we'll select the top menu, File, Close, which will close the current document, and then create a new document. Within, we'll create a new body to start our modeling. Let's create our first sketch. Select the new sketch from the toolbar, and then select the XY plane. This sketch will be similar in shape to the previous one, but our approach will be different, just so we can learn the polyline tool, where we'll utilize its different modes. Activate the polyline tool by clicking on it, and move the cursor into the 3D view. Hover over the vertical axis until we see a point and object constraint, and click to attach. Move the mouse to the left, approximately 25 mm away. Exact placement isn't critical. This will be resolved with constraints. If you are too close or far away and having trouble, use a zoom to get a better fit. This line needs to be straight, and we can see the horizontal auto constraints appearing as we move the mouse. On purpose, I'm going to make this at an angle, so we can understand how to straighten the line later. Left click to add the line. Now we'll create the top fillet. Move the mouse to the end position of this fillet, cut in the corner. The hint in the status bar tells us to press the M key to change the mode. Press the M key. A line will appear travelling downwards. Press M to toggle through the modes, until we get to the arc. Move the mouse to adjust, and then left click to add the arc. Moving the mouse after creating the arc, we'll see the joining line will automatically be tangent to it. If this direction is incorrect, press the M key a few times, until we get the vertical line. We'll fix the tangency later. Move the mouse down past the horizontal axis. Use zoom and view adjustments to stay comfortable. Continue in this manner until you close the geometry profile. Don't worry if it's not perfect yet, we'll clean it up with constraints. Right-click to exit the polyline tool. Of course, you're free to use the rectangle and fillet method from before if you prefer. This is just another way to sketch. If you drag the elements of the sketch slightly, you'll notice a few issues. First, let's make sure the top and bottom lines are perfectly horizontal. Activate the horizontal vertical constraint tool and select the top line. Here the bottom line is already constrained. Right-click to exit the tool. Add constraints to the vertical line if necessary. Next, add tangent constraints to make the straight lines flow smoothly into the arcs, which will create the filleted corners. Select the tangency constraint. Select a line and the adjacent arc. A message will appear, which will click OK. Repeat for all tangent connections. Now let's add the holes using circles. Select the circle tool. Hover over the center point of the top arc and we'll see a coincident constraint appear. Click to place the center. Then move the mouse outwards and click again. Repeat attaching to the bottom arc. Let's add some dimension constraints. Activate the dimensioning tool. To dimension the width, select the leftmost point, then the rightmost point, and place the dimension and set it to 25 mm. To do the same for the height, we have a single line that we can dimension. Select the line, place the dimension and set it to 50 mm. Now we'll dimension one of the circles and set it to 10 mm. Then dimension the arc and set it to a radius of 10 mm. Right-click to exit the dimensioning tool and now use the equal constraint to make both circles the same size. And whilst the tool is still active, make both arcs the same size as well. The sketch still has 1 degree of freedom. It can move along the vertical axis. To fully constrain it, make sure you have nothing selected and select the symmetrical constraint. Select the topmost point and the bottommost point. Then select the midpoint, the sketch origin. This will apply the symmetry constraint. The sketch should turn completely green, meaning it's now fully constrained. Now we can exit the sketch by clicking Close in the task panel. On exit, the sketch will be automatically selected. If not, click on the edge of the sketch once, then again, which will select the entire sketch. We can also select it in the tree view. Now it's selected, click on the pad tool and set the length to 5 mm. And then click on the 3D view to see the effect. Click OK. We can now see the base of the bracket. Next, we'll create the side part of the bracket. Select the vertical face of the pad and click the sketch icon to create a new sketch attached to that face. Then adjust the 3D view so you have plenty of space to work with. We're going to import some geometry from the bottom edge. In doing so, we can tackle this in 2 different ways. We can either import as reference or defining. Let's take a look at both and see how they differ. This time, we'll tell FreeCAD which mode we want before we start importing the geometry. Select the Toggle Construction Geometry tool, or right-click, Toggle Construction Geometry. The tools will now be in blue, showing we're in construction mode. We can now import some geometry using the External Projection tool. Select the tool, then select the 2 top corner points from the previous feature. They will appear in purple in the elements list. Right-click to exit the tool. Make sure we have nothing selected and use the Toggle Construction Geometry tool to toggle the tools back to defining geometry, so they now show in white. Now use the Line tool to draw a line connecting the 2 points. It should turn green as it becomes fully constrained because the points are fixed. So we imported geometry as reference, 2 points, and created a line between them. This line was defining geometry. So with the new external projection tools, if we keep in defining geometry and use the external projection tool, when we import the line instead of the points, this comes in as solid. We can then use this instead of sketching another line, making our workflow a lot quicker. As you can see, it's still fully constrained. Let's carry on with the line and create the rest of the sketch. For the curved parts, select the Arc by 3 Points tool. This is available by clicking the small down arrow next to the Arc tool. To access the other Arc tools, hover over the first point. A coincident constraint appears. Click and move the mouse to where we want the second point. Click again to accept that. If we move the mouse now, we start to affect the size of the arc. Once happy, click again to accept. We'll repeat this on the other side by hovering over the second point and running through the same process. Click to attach, click to where we want the arc to end, and then move the mouse to the correct size and click again. Now we can right click to exit the tool. We'll now create lines attached to the ends of the arcs. Select the line tool and hover over the end of the arc so it's coincident to it. Click and move the mouse up to draw the line. Watch the mouse pointer and look for the vertical constraint. Click and the vertical constraint will be automatically added. We can use the horizontal vertical tool to add the constraint later if needs be. Repeat for the other side. Once finished, right click to exit the tool. Now use the tangent constraint tool and add a tangency between the bottom line and the left arc. Confirm any messages by clicking OK. Repeat on the other side. Then we repeat with each of the lines and its adjacent arc. Select the arc by 3 points from the toolbar again and close the top of the profile, hovering over the point of the left line so we're coincident, and then the point of the right line, and create the arc. Add a tangency constraint between the line and the arc on both sides. And right click to cancel the tool. To keep everything centered, select the center point of the top arc, and then select the vertical axis and apply the coincident constraint, which is a combined tool for both coincident and point on object constraint. We can see if we drag the geometry, because it's tangent, everything will stay symmetrical across the axis. Now let's add some dimensions. Activate the dimensioning tool and select the bottom left point. The sketch will go into redundant constraint, shown as orange. This is normal because the part is already centered, and the default behavior dimensions to the center point, the sketch origin, which is not needed in this sketch. We need to make another selection. Dimension vertically to the center point of the arc. Make sure the dimension is vertical, click and set it to 30 mm. Whilst the dimensioning tool is still active, select the top arc and add a radius dimension and set it to 10 mm. Finally, create a hole by adding a circle. Place its center coincident with the center of the arc, and then set the diameter to 5 mm. The sketch should now be fully constrained. And now click Close in the task panel. We've added a new sketch attached to the face of the previous pad. If you pad this sketch now, it may appear to do nothing because it extrudes in the wrong direction. In the pad panel, click Reverse Direction. Set the length to 5 mm and click OK. You should now see the first completed part of the bracket. Finally, rename the body for clarity. Right-click on the body in the tree view, choose Rename, and call it Bracket. Don't forget to save your project before moving on to the next step. Though ribs and gussets don't have a dedicated operation in FreeCAD, they can still be modelled quite easily. We'll take a slightly longer route first. This will help demonstrate how profile selection affects the build and allows us to explore a dress-up operation. The chamfer. Before showing a quicker and cleaner solution, let's start by selecting the face where the gusset will run down and across. With the front face selected, create a new sketch. The sketch is mapped onto that face, but you'll notice it intersects through the model. To see the sketch clearly on its plane, use the Toggle Selection View tool, or right-click Toggle Selection View. Now we will use the External Projection tool to import the bottom edge. This is the line where the gusset will meet the base. Remember to use the toggle construction geometry tool to switch to construction mode. You'll see the tools in blue. This line will serve as a reference. Once imported, make sure to toggle back to defining geometry, so the tools are shown in white. Activate the rectangle tool, and if needed, use the view sketch icon to reset the view. Hover over the imported line so a point on object constraint is automatically applied. Then sketch the rectangle. Right-click to exit the tool. To center the rectangle, select its top left and top right points. Then select the vertical axis and apply the symmetry constraint. The rectangle is now centered. Let's add some dimensions using the dimensioning tool. Select the top horizontal line and set its width to 5 mm. Select one of the vertical lines and set the height to 20 mm. The sketch should now be fully constrained. In the task panel, click Close. Our sketch touches the top face of the base. When we pad it by making sure the sketch is selected and use the pad tool, the extruded volume will create the gusset. Set the length to 20 mm and hit OK. Notice that the new face has merged with the existing geometry. This happens because the pad reaches exactly the same plane as the adjacent face. FreeCAD will automatically refine features and merge these faces. Next, we need to create an angle cutout at the top of the gusset. There are many ways to do this, but we'll introduce a dress-up feature, the chamfer. Select the top edge of the gusset and activate the chamfer tool. Material is immediately removed. In the task panel, increase the chamfer size. As you move the value higher, you'll see the chamfer grow. This is one of the reasons I wanted to demonstrate this approach. When you try to set the chamfer size to a full 20 mm, matching the gusset height, the chamfer will fail, and the preview reverts back to a square edge. This will actually cause an error if we OK it. To solve this, set the chamfer size to slightly less, i.e. 19.99 mm. This separates the two edges, but makes the remaining material negligible. It's an important behaviour to watch out for future modelling when using dress-up features such as the fillet or chamfer. It's caused by limitations in the underlying Open Cascade CAD kernel, which FreeCAD is built upon. Click OK to confirm the chamfer. We now have a finished bracket. Remember to save your project. So as said before, this is not the cleanest route. It can cause problems later due to the limitations of the dress-up. In parametric modelling, you have the flexibility to go back and modify previous operations as we saw before. If you increase the pad length to 23 mm, everything remains fine. However, if you reduce it to 18 mm, the chamfer will go into error, shown by an exclamation mark on the chamfer feature. This happens because the chamfer is trying to cut across an edge or share the same space as an edge. To fix it, you need to reduce the chamfer size slightly to allow for the new pad height. It demonstrates why dress-up features are left to last in the modelling. If these were earlier features, they will create a fragile dependency in your model. Let's fix the error by setting the chamfer back to 19.99 mm and the pad to 20 mm. The chamfer should once again be stable, and we can continue. A much simpler approach is to create the gusset with a single sketch. Before we create the new gusset, let's clean up the previous feature. Delete the chamfer, then delete the pad, which created the earlier gusset. The sketch will then be released. Go ahead and delete the sketch as well. Now we'll create a new sketch for a simpler triangle gusset, centered on the part. This time we need to sketch on the XZ plane. There are two ways to attach the sketch. Make sure nothing is selected, then click the sketch tool. This will attach the sketch to the base planes of the active body, known as the origin planes. You can then choose the XZ plane from the list. Because our model is centered, it lines up nicely. The second method, which we'll use here, is to attach directly to the planar face. Select the vertical face of the pad that lies on the XZ plane. Then click the Sketch tool. The sketch is now attached to that face. At this point, notice the orientation. The red line is the X-axis and the green the Y. This is related to the sketch. But if we look at the navigation widget, the Y-axis points in a different direction. Think of this as though you have a drawing board and attached to it is a piece of paper. The drawing board is your face, the piece of paper is your sketch. The piece of paper is 2D. It has X and Y axes. How far that piece of paper is away from your drawing board will be along the Z, known as normal to sketch. To position the sketch, select the sketch in the tree. In the attachment section of the properties panel, not the placement, you'll see it's attached to the face with a map mode. Flat face. Change the attachment offset along the Z position to a value of -25mm. This will move the sketch into the correct central position. Because there's solid material in front of the sketch plane, it will intersect through it and be obscured from the view. Use the toggle selection view to cut through the model so you can see it clearly. Now let's sketch a triangle. First, use the external projection tool to import the back edge and front edge of the base. They will appear as points because we're looking straight on at the lines. Also import the vertical edge. As we've forgotten to activate the construction geometry, we will box select all of the elements from the screen. Right click to cancel the tool. Click and hold and draw a selection around the elements and release to select them. And then use the toggle construction geometry tool to convert it to construction geometry. Activate the polyline tool. Start by hovering over the back imported point. A coincident constraint will appear and click to add. Draw a line horizontally and connect the front. Draw a line upwards and attach the top point to the vertical imported edge via a point on object constraint. Then close the triangle by connecting back coincident to the starting point. We can now right click to exit the tool. Now add the dimensions. Select the vertical line and set it to 25mm. The sketch should now be fully constrained. And we can click close. If the sketch isn't already selected, select it and now use the pad tool. By default, the pad extrudes in one direction. To make the gusset symmetrical, enable symmetric in the drop-down. Set the length to 5mm and click OK. We've now added a clean gusset with far fewer operations in the body's feature tree. If we expand the pad of the gusset, double-click the sketch and change its dimension to 15mm. When we exit the sketch, the changes have applied without error. Let's return to the sketch and change this back to 25mm. There are many ways to change the appearance of a part. We can apply a random colour, colour individual faces, or assign a material to the entire part. Let's open both parts by going up to the top menu, File, Open, and select the base, and then repeat the process for the bracket. In the model panel, we can see we have two documents in the tree. Double-clicking on a document, we'll set it as the active document, telling FreeCAD which one we want to work on. We will first work with the base part. If you haven't already, double-click it in the tree view. To assign a random colour, select the body from the tree, then right-click and select Random Colour. The model will change colour. There are two tabs in the lower left corner, one Data and one View. Click on the View tab and select the body from the tree view. In the Properties, expand the Shape Appearance section. It will show the colour that has been assigned. You'll find options such as Diffuse Colour, Ambient Colour, and more. Diffuse colour is the main base colour of our part. It's what you see as the overall colour when light shines on it. This is usually the only colour you need to change for most models. Let's change this by clicking on the diffuse colour swatch. A colour selection panel will appear where we can choose the desired colour. And click OK. FreeCAD has a library of materials that can alter the appearance. To assign a material, again go to the tree view, right click on the body, but this time select Appearance, not Material. The display properties will appear in the task panel. The drop down at the top tells us what view mode is currently assigned to the selected object. If this is blank, it means we haven't selected anything. So we need to select the body from the tree view. It will now display the body's display properties. The material section may be collapsed. Expand it to see a list of available materials. Let's select aluminium. You'll see the part update. Whilst the display properties are still open, double click on the bracket document in the tree, swapping to the other part. We can now assign this part of material while the display properties are still open. Once finished, close the properties. Remember to save the changes to the documents by going up to the top menu, File, and Save All. To export your model with FreeCAD, select the desired body or feature in the model tree. Then go to the top menu, File, Export. In the Export dialog, you can choose the file type from the drop-down. You'll see STEP, FreeMF, and several other formats. Note that some formats have multiple extensions. For FreeMF, the main extension is .freemf. Select FreeMF, choose a location, and click Save. Your model is now exported as a FreeMF file. We can import this back into FreeCAD to check the results. Let's create a new document. Go to the top menu, File, Import, and select the FreeMF file you just exported. One powerful feature in FreeCAD is the ability to export the model at any point in its history. Let's return back to the bracket document by double-clicking on it in the tree view. Let's select a specific feature. For example, I'm going to pick the pad before the gusset was added. Make the feature visible so you can see it in the 3D view. Then make sure you select the feature. Go to the top menu, File, Export, and we'll choose FreeMF again, and save it with a name like bracketpad.freemf. Let's switch back to the document we created earlier, and delete the old mesh from the tree view. Import the new file back in. Top menu, File, and Import, and then select the file. You'll see only the geometry that exists up to that pad operation. All later features, like the gusset, are not included. Let's delete the mesh from the tree view and return to the bracket document. And make sure that the last feature is visible in the tree view. So now we want to create two versions for one part, one with circular holes and the other with slotted holes. Duplicating the file and editing the sketch in the copy would work, but any future changes would need to be made twice. Instead, we'll use the Part Design Clone tool, which will let us create a linked parametric copy of the body, so both versions share the same features. The holes are currently in the first sketch, which makes cloning difficult. We first need to move the holes to the end of the feature tree. I already have the bracket loaded. The first thing I need to do is look at my tree view and make sure that the bracket itself is in bold, so it's active. If I right click on this at the moment, we can see the active body is not checked. Let's just check that. It is now in bold. If we look down, we can show the first pad, and we can see the holes within. Let's expand the pad and double click on the sketch. In here we can see the 10mm holes. Select one and then select the other. This gets added to the hungry selection, and we'll hit the delete key, removing those holes. We can now close the sketch and show the last operation. Those holes have been removed, and now we select the top of the face and create a new sketch. Now this sketch will be on the same plane as this face, and if we add some angle, we can see where that's intersecting. Select the view sketch to reorientate the view, and I'm just going to select the toggle section view to cut through that. The geometry is in white, so we're in defining geometry mode at the moment. We'll use the toggle construction mode. Now we're in construction geometry in blue. Using the external projection tool, we'll click it and import the fillets from both sides. So what we see is a point in the middle. We can now swap back to defining geometry, making sure these are still dashed, and select the circle tool. If I hover over the center point of the fillet, we can constrain the circle coincident to there and type in 10 millimeters and hit enter. Let's repeat for the bottom, and we'll right click and just use the equal to make sure that these two circles are equal. I can see that this point isn't constrained. Right click to cancel the tool, click and hold and create a selection around these 2 points and use the coincident. We're fully constrained. We can hit close. We see the 2 circles. The sketch is already selected, and now we'll use a pocket, and we can either pocket through all, or we just go for 5 millimeters and hit OK. Created the holes now. Now these live in the pocket operation. So we've set up the workflow ready for the clone. Let's collapse all of the operations within. Using the eye icon, let's backtrack through the sketches, making sure the pocket is invisible. So the tip operation is the pocket. The next one is the pad. And this is where we want to branch from. Select the pad and then use the clone icon from the toolbar, or come up to part design and clone. Look to the left, we have the bracket. Let's make sure that the last operation of the bracket is still visible and hide the bracket. What we're seeing now is the cloned body. This one here, we can see it highlighted there. So the clone is in exactly the same place as the bracket. We can see that there. If we look at the body, it's not active. The bracket is still active. Let's double click the body or right click and select active body, and inside we see the clone. If I click on the clone, it's showing which base feature it's come from, pad 002, the one we selected. So I've branched from this pad here and created a new workflow. Let's rename the body, right click, rename, and we'll call this bracket slot. It's in bold, it's active, so I can take the top face, create a sketch upon that face, toggle the section view, and repeat the process, pulling in the geometry here, making sure we're in construction mode, and making sure these come in as dashed. Otherwise, we need to select them and use the toggle construction geometry. Let's right click to cancel the tool. Make sure these are toggled back to defining geometry. And this time we'll use the slot tool and create a slot in here. Now, depending where we want this, I'm going to create a slot here, like so, and the same down the bottom. Right click to cancel, and let's zoom into the top slot. This is the imported point. Let's take these 2 points and then the center point, make those symmetrical. And we'll pull these in and set a distance between these 2 points using the dimensioning tool. We'll set this to 10 millimeters and hit OK. And then dimension the arc, setting it to a radius of 2.5 millimeters. Let's right click to cancel and use the equal constraint. Make the arcs equal and then make these lines equal. Right click to cancel the tool. We'll create symmetry between these 2 points and the center point using the symmetry constraint. So we're fully constrained and all our dimensions are controlled from this slot. Let's hit close now. Take the sketch and create the pocket. Going down 5 millimeters, that's fine. Let's hit OK. And now we've got the slots. So now we've got two versions. We've got the bracket slot, and if I hide that version and show the original bracket, we have this one here as well. So the original bracket has larger holes than the slot bracket. So let's change that. I'm going to hide the bracket and show the bracket slot body. Inside the pocket, we have the sketch. The bracket slot body is active, so we can double click the sketch, and now we just have to adjust this top slot and the bottom slot will follow. First of all, the radius. This has to be 5 millimeters, as the previous holes had a diameter of 10 millimeters. Now the length here. At the moment it's 10 millimeters, which is pushing it out the side. Let's double click the 10 millimeters and we'll adjust this by eye. Now to do that, we have this reference here. We check the reference checkbox and hit OK. You notice we're under constrained and the geometry has gone white. This is now a reference dimension, which means it just holds reference and we can adjust the hold to whatever we want. So I can eyeball this into position. I'm going to set a length of 5 millimeters. At the moment we have the reference. Let's double click it. We can see the length is 5.14 millimeters, where we eyeballed this in. And we change this to 5 millimeters. Note the reference has become unchecked. Let's hit OK. And now we're back to a defining dimension and we're fully constrained. And we can close and we see the changes have taken effect. Remember to save. We've now completed both parts. So we've created a variant of our bracket using the clone workflow. Let's demonstrate the clone workflow by right clicking on the bracket in the tree view and using the transform, and we'll move the body over to the right and also make the other bracket visible. So we can see both side by side. Let's hit OK. So we have the two brackets visible. Let's say I wanted to change the size of this hole here. I'm on the bracket slot at the moment, and you can see the only operation we have is the pocket in here. This means that if I cycle back through to the operation that created that hole, which was pad 001, this is on the original bracket, and we edit that sketch and set the 5 millimeters to 15, hit OK. If I hit close, we can see the effect, and if we show the last operation, the pocket, we can see the effect has been passed through to the clone. So any modifications we do in here will affect the variance that are derived from it. Let's hit close. So that's a quick introduction to FreeCAD. Hope you enjoyed the video and hope to see you in the next one. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Coffee at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.